Alright, let's start the project tour for the Python search algorithm visualizer. First, I'd like to motivate the project. I was inspired to make it by my friend M, who made a similar project, and by the amazing book Artificial Intelligence, A Modern Approach by Russell and Norwick. My goal with the project was to make a non-trivial Python project and to make a graphical user interface. The first thing I did was to set a scope, so I made this GUI concept draft. As you may notice, the final product does look different, but clearly it still resembles the draft. I'm happy I made this draft instead of jumping headfirst into implementation, because this vision ultimately sped up the implementation. And towards the end of the project, when I got the idea of having the heuristic pop-up window, I also made a draft for that. Along with my initial draft, I also wrote down some requirements for the application. They're like rough user stories explaining what the user should be able to do and how the application should behave. All right, let's try now to jump into the project. I have a test folder and a main folder. I wrote tests for the majority of the model logic. Some tests I wrote in a TDD style ahead of implementation, and others I tested after implementation. I did not make tests for the GUI, as I thought GUI is difficult to test in code. Such tests can be very fragile since, as you saw earlier, the GUI changes over time. So instead, I just did informal manual testing of the GUI by interacting with it and trying out the different features. Of course, this is also not completely robust, but ultimately I stand by this decision. In the implementation, I wanted to be somewhat agile by delivering quickly. So instead of implementing all of the algorithms immediately, I decided to implement first only the best first search. And let's find it now. Okay, so as you can see, it inherits from the informed searcher and is a very small class. This structure with the informed searcher made it implementing the other searchers very easy as well. And while it looks like informed searcher is inheriting from 3 classes, algorithm description is an interface and so is ABC effectively as well. So we still have single inheritance, just a little Python quirk. And let's see, all of the searchers use the frontier interface, which is an interface implemented by the data structures. And for the fun of it, I wanted to implement all of these data structures myself. I was especially excited to implement the priority queue with a min heap. And initially I wanted to really optimize its performance, so I looked into Fibonacci heaps, but from what I could tell, they are quite tricky to implement and in practice don't perform much better than other heaps because of the constant overhead of all the pointers. So, and unfortunately I also implemented skew heaps, which were developed by Sleater and Tarjan in 1986, before I realized that the heap decrease key operation would be too slow to make skew heaps a good fit for search algorithms. And I kept this one here because I just couldn't get myself to delete it. But yeah, ultimately I went with a simple min heap implementation. And although it's not the fastest, it's certainly good enough for the small search problems in this project. All right, let's get into the GUI. Maybe I should start by mentioning that I used the MVC pattern with a controller model and a view to separate the GUI logic from the model logic. And effectively, I made sure that the view and the model always communicate through a controller. This made for a good separation of concerns. I also implemented the observer pattern with this publisher class to facilitate the communication between components. All right. I divided the view, whose mainframe is the search window, into the left pane and a right pane. And while naming based on position may seem fragile, it ended up working great and really helped in navigating the project. All right, the search window in the top level is only 140 lines because I separate the code of the window into the child widgets that compose it. So we have the create left pane, which creates all of the panes that we see on the left. And even these will simplify further by also being composed of their own subpanes. All right, but I'm not really gonna go over all of them, so let's just check the grid widget. The grid widget is where the magic happens. In this class, the GUI twin of the model is stored. It's quite a large class, and if you argue that I should divide some of its responsibilities to other classes, I could agree with you, but at the same time, it's less than 300 lines of code in a scoped project, and everything here is highly cohesive in my opinion. So I chose to keep it this way still. All right, that's what I wanted to show. I hope this made clear what I wanted to achieve with the project and how it is structured. Have a nice day.